Good morning, friends. Today I am going to discuss about control charts for variables, and under the subject topic, statistical quality control, or you can say under the subject name of statistics for manufacturing. Okay. So this one, what we are trying to do here is how we are going to control the quality through some collected information. Okay. That collected information is in the form of chart, or we can say that control chart is nothing but the graphical representation of collected information, okay, or the gathered information or the data, which is going to be the crux. That means statistical, that means the only in terms of the numbers I am going to collect these things. Okay, try to understand this one, because collected information in the form of statistics means it has to be in form of certain numbers. These numbers can be got by actually counting one thing. Second thing is, these numbers can be got by one thing I told, by actually counting. The second thing is by actually measuring them. If it has got a measurable characteristic, that is what we need to understand. If it is a measurable characteristic, then only I am able to measure it. For example, here, what I am trying to do here is, this is some casting. Okay, this casting has got a particular length, width, height. These dimensions need to be controlled, or they have to be within the permissible limits. Second thing, it has got its surface roughness or surface finish is required. Third, it may require some holes are to be drilled, and again their dimensions or whatever it is. Then the two cases will arise here. Am I looking at this casting, this entire thing as a whole, as one thing? In that case, either I will accept this casting or I will reject it. And second thing is, if I am able to measure only one characteristics, if it doesn't meet one of the characteristics, it will be rejected. But sometimes what happens, most of the time, length, width and height will be met, but the surface finish may not be proper, only because of the imperfections of the surface finish, it might be rejected. In that case, each of these dimensions, okay, have to be maintained, and the control chart has to be maintained for each of these things, which are measurable characters. And if it is either accepted or rejected, that means I am not going to measure it. Then it will become the attribute type of characters. Okay, that means any product, may have measurable characteristics or attribute characteristics. If it has got the measurable characteristics, we call it as the variable characteristic, because length, it can vary. Even if you look at the people, okay, maybe the height, male height might vary generally between 5 feet 3 inches to 6 feet of Indian male or whatever it is. That is what we say. It has, because it will not have the same thing. Everyone will have the same height and other things. They cannot have, anything cannot have they have the same thing. That means they are not identical in all the respects. Of course, it has been said that in the world, maybe at the most, only 7 people will be having the same characteristics, or they are identical in nature. Because out of maybe how many billions, you can just say maybe about 7 billions, 700 billion, this one people, 700 billion people, we can get only 7 out of 700 billion, only 7 will have the same, the characteristics, or they are identical in each respect. That means what? In each and everything, there is going to be a variation. That is what is to be understood. That is, variation is inevitable. One thing is, because this subject itself, or statistics and other things, or the controlling of quality, we are going to presume that there is going to be variation irrespective of what we are able to do it. This variation, is it within the permissible limit or not? That is what will constitute the thing. For example, nowadays we are passing through the difficult period because of, yes, COVID-19. Now, earlier, the natural death will occur, because there are two things now. Natural death will occur as it is, and in addition to this one, now because of COVID-19, some deaths will take place. Or suddenly if we find that there is an abnormal rise in the death rate, then we'll try to find out the reason, what is happening. That is how the people, the physiologists and other things, they found out that it is because of certain virus. That is why so many people are being affected and so many casualties are there. So we can assign certain cause, or there is, if this variation is there, we can assign certain cause, or assignable, we can assign certain reasons for that cause. What is the why? Immediately the why there is an increase in the death rate? Yes, because of this COVID virus. Otherwise, people are dying day in and day out. We are not much bothered, because we cannot assign any reason to it. Because of that one, we can say that natural thing. Natural is one thing, unnatural is another thing, or natural means whatever we do, it is going to happen like that. But if it is an assignable cause, what we will try to do? We will try to identify the cause and eliminate that cause, reason, so that we are going to have the control over it. So in any process, there are two things. One is assignable cause, the variation is there, variation is inevitable, and this variation may be due to the natural reason, and second one is it might be some created, or suddenly it has come out, or it might be because of the unnatural thing, or we can say that in this quality terminology, is there any reason I can assignable causes? Natural causes, and we can say that assignable causes. One is natural cause, another one is assignable cause. Okay, to control the quality, what we'll try to do? We'll try to reduce this natural causes so that good products will be produced, and we want to eliminate these causes which have got a certain reason, or assignable causes are to be eliminated. Because these are the two reasons why there is going to be a variation. Are we able to get this one, distinguish this one? Because if I want to produce certain items, say for example, I had given this one, how it is to be produced then? We are going to get the casting. These castings are manufactured. Before that one, I will try to put one more condition. If I want to control the quality of this one through the control charts, then I need to see how many numbers of these things are being manufactured. If there is only one casting, then there is no question of preparing the control charts and analyzing it and other things. No question about that. No point in doing this one. So if several numbers of the similar things are being produced, then we can think about these control charts. That is why, my dear friends, or student friends, you try to understand who developed these control charts, under what circumstances. Because these control charts were developed by one Mr. D.A. Seward. Okay? They are known as Seward charts as well. Seward chart, D.A. Seward. He developed these things for controlling the quality in the year maybe in 1920s. During that time, we try to understand which one was more prevalent, whether the job type of production, because if we look at the type of production, it might be job production, it may be mass production. These are the broad categories, mass production or batch production. So in fact, job production means only one item will be produced. Mass production means several, maybe in hundreds and thousands of that one. And batch production is in between, a typical batch, maybe around 10, 50, like that. Say for example, if we want to manufacture the aeroplanes or warplanes, whatever it is, it might be in terms of tens or 20s or hundreds at the most, that's all. But whereas the other things, if we look at it, mass produced items, the cars and other things, they are being produced in terms of thousands. So that one we need to understand. Job type of production, say for example, the shift production or only one time it is being produced. So for which type of production it is applicable, that is what we need to think. Because it might be one objective type of question where the control charts are being applied. They are not being applied to job type of production because it is only one job and it has to be one-to-one relationship with the customer and other thing. Everything is known. Whereas in mass type of production, nothing is known. Who is manufacturing, where it is manufactured, nothing is known. Who is going to buy and other things. So in that case, because in job type of production, we will continuously interact with the customer and try to go on checking it, and he will come and see it, and he will go on checking it. Hence, we will be able to produce the things towards the satisfaction of the customer. But here in mass production, customer is invisible, but yet he is going to decide about the product by buying it or not buying it. That is why it becomes more peculiar thing. And during 30s or 40s, what happened? This mass production was at its peak. But of course, now what has happened? Now we have come down to neither job production nor mass production, but we are in batch production type of area. Everything is produced in batches. Because if we look at it, or maybe you may feel that it is out of the coverage of this one. But if you look during 1910 or 1918, when the assembly line for manufacturing of the cars for T model, Ford T model was designed, then Henry Ford said, so you will buy the car, customers will buy the car, but it is going to be only the black. But he failed. That means what? That time the mass production was at its peak, and he thought that it is only the cost which is going to matter much. Yes, he could be able to reduce the cost from then $900 a car to $150 a car. A phenomenal decrease in that one. He was able to do that one, but he could not satisfy the customers because their thinking or their aspirations were different. That is how General Motors took over the Ford in 1920 or something like that. That means why I am able to tell this one is, during that era, mass production was there. So then they wanted to control the quality of these several thousands of the products. Actually, when they are going to be produced, they started thinking whether they are meeting the quality standards or not. It is into the process. under the production process. But I am able to predict at the end of the process, yes, I am going to produce the good items only. Or if I am not producing the good items, it should be able to reveal this point of time so that I can take the corrective actions. So it is applicable for this control charts. They are applicable only for repetitive type of processes. That is my intention. Not for job type of production, no. It is not a repetitive process, it is one time. Whereas mass production, it is repetitive, yes, it can be applied. And it can be even applied to batch type of production. Okay, to maximum extent in mass production. And this one, batch production to a limited extent. Okay, because there also we have got the flexibility and other things, and nowadays the sophisticated machinery like CNC and other things, which has enhanced this aspect. And now we'll be talking about that one. But whatever we are studying, it is concerned with repetitive process, and that is the mass production that you need to keep it in your mind. Okay. Having said that one, now we'll come back that means in mass production, several thousands of identical things are being manufactured. Then our nature or whatever it says that no two things are alike, whatever we do. That is also once I mentioned, out of 700 billion people on the earth, only it is said, out of 700 billion, maybe one can say only 7 people are alike out of 700 billion. You can just think. So that means the variation is natural. We cannot do anything about it. But only thing is, if the variation is natural, then are we able to tell, is it because of the natural variation, or this variation is because of certain other factors? That is what I brought in this COVID-19. Because suddenly what they started observing, the death rates, it started increasing. Naturally it is there, because how many people will die and other things, even if you cross-check it and other things. I am not here to dispute about whatever it is. Maybe on a general, maybe 1 crore people might die in India, or if we work it backwards, maybe around 30 to 35,000 people in a day, they are going to die, whatever it is. But here COVID-19 or whatever it is, if you consider, maybe because of the same disease, more number of people are dying, then it is the cause of worry. Then are you able to, whether we are capable of controlling that one? That is what we are searching for, the vaccination and other things for that reason. Try to understand. The similar thing, because here we talk about, in medical terms, we talk about the death rate. And when we are manufacturing something, if it is defective part, we want that all the good parts. If it is defective part, that means it is not useful for me. It is as if we have produced something which is of no use. So I need to understand why I am producing this defective part itself. If out of earlier thing was what we try to say, which industry used to be good, because I have to go down before going in detail about this one. I am trying to build up certain things, background, why we need to study about this control charts and other things. For that reason, I am trying to explain these things. Otherwise, I would have just said, if I go through the syllabus, what is the definition of control chart? What does it consist of? What are the various causes and other things? It will not be of use. Okay. So now, if I look at these aspects, okay, then we'll come to know that there is going to be the variation, and variation is inevitable. And these variations are due to be 2 reasons. One is natural reason and another is unnatural reason. If it is a natural reason, leave it as it is. We cannot do anything about it. If it is unnatural reasons, then we will try to control it. Why it is being caused like that? That is the crux of it. Now, if you look at it, this variation, how much variation, that means what? How much defectives we are able to produce. Earlier, the people used to say that, you just see how the phenomenal growth has taken place in quality area, or how the quality control, it helps us. Earlier, if any factory is manufacturing, if it is able to manufacture, say for example the casting itself, if it is able to manufacture 97% good items, that means good castings, only 3% are being rejected. 3 or less than 3% are being rejected. One used to say that it is a very good foundry. But slowly it changed. Then they started thinking, because when we applied the 3 sigma limit, because this particularly this 3 has got more significance. So earlier we said, if the rejection rate is less than or equal to 3%, it is very good. Failure rate or whatever you can think about it. Second, then they started thinking 3%. Then they said, no, not 3%. 3 defectives out of 1,000 items. What this one? That somehow they came to the conclusion, that means it might work out to be 0.27% to 3.3%. What this one? The shift. That only it is good. That it increased the quality by 10 folds. Where is 3% and where is 0.3%? Or we can say 0.27%. Then we applied, we said 3 sigma limit. That is what we started calling it as. 3 sigma in the sense, if between the mean mu plus or minus 3 sigma limit, if you consider under the normal curve between plus or minus 3 sigma limit, how much area is covered is 99.73% of area is covered between mu plus 3 sigma and mu minus 3 sigma. This area, if you are able to measure, so it will say that how much area is covered is 99.73%. That means they are good. Outside this one is 1 minus or 100% minus 99.73%. It was out is 0.27%. Try to understand this one. So which is, now they started. If there are somebody is manufacturing only 3 of defective foundry out of 1,000, then it is good. Then the new era came. Okay, Motorola and other things, they said, they didn't stop at this. They talked about 6 sigma. 6 sigma limit. Earlier it was 3 sigma limit. Then they talked about 6 sigma limit. Or at the same time, the Japanese talked about 0 defect program. What it means, out of million parts, only 3 will be defective. Just see the shift. Out of 10 lakhs, one can manufacture only 3 or 4 defectives. That is the scenario now. That is what is called as 6 sigma limit. How these things are to be achieved? How it was achieved? What could be the reason? How one can go step by step to achieve this one? That constitutes the subject matter of this one. This is the basic background about this. You try to understand, this is most important. Because now we are in the era 3 sigma limit, so 6 sigma limits, not 3 sigma limit. We started with 3%, then we passed through 3 sigma limit, and now we are in 6 sigma limit, or it is almost, that means 3 defectives out of 10 lakhs means almost it is 0 defect. That means whatever we manufacture, they are all good. How it could be achieved? That means they said variation is there, right, but can we able to reduce that variation itself? Because certain things, they have got larger variations. These larger variations are due to few causes. Okay? Because that is what they say. In general, in the management, we used to talk about trivial many. Trivial many. Vital few. That means if rejection is increasing, there are only few causes, one or two causes, which will cause large variation. And there is another thing, small variation, which will be caused because of several things, several reasons. There is no point in tackling about those things because maybe 100 reasons will be there, assignable causes. Then I cannot say it is assignable causes. There are 100 trivial. So first we will try to find out which is significant and then try to identify which is not significant. Then I need to draw the line between these two. Is it natural or is it due to certain other assignable cause? If so, is there any magic wand which can tell me, yes, you are going to produce or you are going to produce more defective items? Then I am going to take a corrective action. So it was used like a sort of magic wand, or this control charts can be used like that. You are going to produce the defective parts, so before it is going to be produced, you try to identify and it should tell me you are going to produce. It should be because this is the duty of this one is what? It should be able to tell us whether the process is going to produce the defective parts, if it is continued in the same way, or it is not going to produce the defective parts, so don't touch it, leave it as it is. These two things it should tell. So under those circumstances, we need to establish these charts. Then they will become control charts. Control limits are to be established. In control chart means what? It should have the limit. What limit? Natural limits. How to fix the natural limit? That is the crux of our problem. Okay. Now, I talked about variation. Okay. In production process, what could be the reasons for these variations? If we analyze, what could be the reasons? Okay. Can you tell me? Variations are due to what? Okay. And dear students, you try to think, because I am talking about the manufacturing sector. There are three aspects over here. Three things will come into picture. What are those three things? One is, inevitably, it should be the person, somebody has to there who has to manufacture it. He will be working on some material and with the help of machines. Because these are three contributing factors. Okay? Several castings are to be manufactured, or certain parts, or say for example, usually the one shaft of 20 mm diameter and maybe something around 50 mm long. Shaft is to be manufactured which has got surface finish or whatever it is. Usually length, there won't be much variation for the length. But we say that the shaft would be rejected because of not meeting this diameter, that is 25. There is going to be the variation for that. It is not going to be exactly 20. It may be more or it might be less or it might be exactly. Maybe if I produce some 100, only maybe some 5 or 10, there will be 20. But variation, natural variation, that means that there are going to be the natural variations because it depends upon measuring system or the measuring tool and other things, one's capability that can be measured. Okay. Earlier it was limited to 1,000 of an inch. Okay. Just like that I am going to give you certain information. 1,000, this is called as 1,000 of the inch. Then we went for micron. Micron what? 1,000 of an mm. That means what? Micron means what? This is also equal to 10 to the power minus 6 meters. We are in what phase now? We say about nanotechnology. Nanotechnology means what? 10 to the power of minus 9 meters. So now we are able to measure up to this capacity. That means I have got the capacity to measure that one. That means I might be having the machine to produce the items like this. So try to think about it. If I go for tau, then you don't find any distance. Almost it is 20 mm only like that. But if you apply this microns, some variation, 0.29 mm, then it will find out. And if you use if you use this nanotubes, then the significant, it will be more significant, more magnified. Try to understand. Okay. Now we are in this area, and slowly we are going to, who knows, or maybe now we are in 10 to the power of minus 10 meters area. We may, within a decade, we will reach this 10 to the power of minus 12, that is pico. Instead of nano, our next generation will start talking about this pico technology. Okay. So you just see how advanced these things and how we are going to address these problems. Friends, here we are going to limit ourselves to 3 sigma limits, one thing, and I was talking about these variations. And because of that variations will also depend on this one. Okay, these are the variations may be due to person working on that particular material. One thing, different people are working on the same material, or there might be variation in the material itself, or there might be a variation in the machine itself, or it might be because of the combination of all these 3, and it may be at particular time, or it might be over a period of time. So we can make these variations into 5 categories like that. What is one? 3 you can understand. One is, there is, because variation is there, because different people, because this 1,000 or 10,000 parts are to be manufactured like that, only one person will not manufacture. They will have put on several machines, several people will be working. They are using the different type of the rod or the steel rod or whatever it is to manufacture the same shaft. It is not being manufactured by the same person, same machine and other things. Even though it is manufactured like that, again there are going to be, we expect that there should not be any variation, but we will try to find out that there is going to be variation, because in that case there might be a natural thing in the machine itself, because there might be slight wear in the bearing, maybe there might be backlash in the nut and dusting movements or whatever it is, or the person who is carrying out this operation itself may have the varying mood. That will cause for the variation. That is how it was identified. Okay, now how we are reaching this nanotechnology and other things is, everything is handed over to the machine, and the machine itself, that is, its condition is being monitored. Always it will be kept in a healthy portion itself. Like that, even in the person also we can see that many of us, it doesn't mean that we don't get any cough, cold or whatever. We do get. But if a person starts getting the cough and cold often, then there is a reason. It is just like that. Not much difference. Okay. If we maintain the things, that is what we feel. Again, these are being monitored. That is what is happening. Because even now in COVID-19 and other things, what is that they are taking? They are checking? They are checking the temperature. That is one of the parameters. That is what they say. Because the fever is there. Is this fever is because of the COVID-19 or not? That is to be further investigated. Then we say that he is affected or not affected, or he is positive or he is negative, like that. Here also same thing. So there they have fixed some temperature limit. Here we are going to put some dimension. And if it is a measurable dimension like this, then we say that it is a control chart for variables. And if it is not measurable, which will just the categorize into conforming to certain specification, and it is not conforming to certain specification, then it is called as attribute. It is rejected, not meeting the specification. Which specification? No. Okay, got this one? That is what we call it as attribute characteristics. Okay, that is, it will confirm, either it will be accepted or rejected. It is nothing but how many things have been accepted, how many have been rejected, only counting. We are not going to actually measure that dimension. Because of what reason it was rejected? No, it was rejected, only that much. If there is a phenomenal, the increase in that one, then only we will take the action. So the first, in fact, the first control chart, what is to be applied is the control chart for attributes, that we will discuss later. Okay. But having maintained the control chart for attributes, we will know which part we need to maintain the control chart. And again, for that particular thing, for which of the dimensions it is being rejected, then I can go for control charts for variables. So this is what we need to understand about this. Okay, this is what I talked about. What are the variations, and these variations are for these reasons. Okay. So this is inevitable, and then I need to think about certain other statistical means, because the statistics for manufacturing, in the sense, basically it revolves around what? It revolves around probability. Okay, and then probability distribution, and how to find out the probability. Or here precisely what we are trying to make out is the statistics for management. So for statistics for manufacturing means what? We will gather with the help of the sampling technique, which we have learned in the second unit. We will gather the information. Okay? What for? For predicting the future. Try to understand. Based on our gathering the information, I am going to predict the future. That means when the process is going on, I will take certain sampling or information. Based on that one, I am going to say that, yes, now I am going to produce 100% good item or 99% good items, like that. So that way it helps. So in that case, we need to understand what is meant by probability and certain statistical tools we are going to use. Mainly for these things, control charts for variables, we will come across two things. Okay? Or if I look at for any statistics, the two things are important. One is the average value. Because why I am stressing on this one is, without understanding this one, we are unable to understand the subject and suggest the things. Okay? And the other things is, especially for you, the numericals will be asked. Numericals will be based on these facts. That is why, even though it might be a repetition, you may have to bear with me. Okay? That's the caution at the outset I am making. Okay? Giving average value. Second thing is variance. Okay? Now, how these things are measured? How these things are found out? That is what we have to see. Because any of the information, collected information, or any numbers we collect. For example, earlier I had given this shaft, and if we are able to measure that one, if I am able to find out that 20, it may not be 20 exactly, 20.05, 20.1. Likewise, say some 50 shafts were measured, they will not be exactly equal to 20. Some may be 20, some may be lesser than this, some may be more than 20. Like that, it will go on varying. But if you observe, they have got the tendency. What tendency they have got? They have got the central tendency. That means these values will be crowding around a particular value, namely the 20 year in this case. That is what we say, that it has got the central tendency. These values have got the central tendency, revolve around certain things. This is the natural thing. Any phenomena, if you observe, it will be like that, just like the satellites around the sun or whatever it is. So they will be revolving around that one. That is what is called as central tendency. Measure of central tendency, one of the measures of central tendency is arithmetic mean. Mainly arithmetic mean, general thing, average, what we call, that is nothing but arithmetic mean, because other things are, measure of central tendencies are mode and median, but arithmetic mean is widely used because it may be susceptible for further mathematical treatment for that reason, no other reason. Okay, that arithmetic mean, that is the average value, that is what we know how to find out x bar or whatever it is, some bar thing which we will be talking about. Okay, so it will say this is how it can be measured. How it is done, say for example, there are some 50 values like x1, x2, x3, like that I have got some 50 values. What is the average value? What I will do, summation of this x1, x2 or x1 plus x2 up to x50 divided by 50 values, it will give me the average of this one. So all these values will be crowded around this. It may have certain advantages and disadvantages, because some main disadvantage being the arithmetic average is affected by the extreme values. Now it is 20, suddenly I may get something around 22 mm or some 21 mm. Another thing might be 19 mm, something like that. In that case, totally it has got the capability to change it. That is one disadvantage. In that case, the usual step taken is you try to eliminate, ignore those things. That eliminating those things, you try to find out the average value. That's the easiest thing one can do. But another second disadvantage of this one is, if you go on subtracting some value from the arithmetic mean, finally we will left with some plus and some minus, finally we will be left with 0 value. That we will see. That is the important thing, because it cannot be subjected for further mathematical treatment. That is one of the weaknesses, and how it is to be overcome, we will see. First thing, that means what? One is average value. How we will find out is by means of arithmetic mean. So 50 value, this is how it is to be found out. Okay, that is what I said. Then what is the variance? Because these x1, x2 values, in fact, they should have been same, but there is going to be a variation. How do I measure this variation? This variation will be measured. Time is up. The 6 minutes. Variation is measured by different means. Somebody said, okay, what will do? Variation in the sense, variation with respect to one to another. Suppose if the 50 values are there like this, I will go on comparing x1 with x2, x1 with x3, x1 with x4 like that, and x2 with x3 like that. Because instead of that one, some fellow said, no, these values, what you do is, You compare them with respect to its arithmetic mean. What this one? You try to find out what is the difference between, suppose, this x1 value, arithmetic mean, we have found out this one as average value as, say, x bar. x1 minus x bar, okay, plus x2 minus x bar, plus x3 minus x bar, like that. x50 minus x bar, you find out. And find out their mean. What is going to happen? Instead of this hypothetical this thing, let me take